Right, take it away, guys.
Okay, thank you very much, everybody. On behalf of the chairman of NSE London UK branch and the chairman of the Buhari branch, I welcome all of you to this gathering of NSE London UK Engineering Seminar. We are grateful that we're all here today, despite the COVID-19 pandemic killing thousands across the world. And for those who have departed, we pray that they rest in peace with their Creator. Amen.
Amen.
Amen. Amen. So we're going to start with acknowledgement of the NSE members, and I think we should always start from the top. We acknowledge the NSE President, Engineer Mohammed Babagana, FNSC, the Executive Committee and Council members of the NSE, hereby present, the chairpersons of all NSE branches hereby present, fellow engineers, associates, and architects, all others hereby present, and sponsors. We are glad that you're here today. I forgot to introduce myself. I am Solomon Arioba, a member of the NSE London branch. Thank you very much for joining us this beautiful Saturday afternoon. We also need to give special thanks to our sponsor, World Dream It, who have been kind enough to sponsor this particular seminar today, and we hope that we can get more sponsors going forward. Can we play the World Dream It video just to understand what World Dream It do? No problem. But it seems like we just saw a video of a very happy customer who successfully transferred money from wherever to Nigeria. So that's World Dream It for us.
Yeah.
Thank you very much. We'll move on to a quick introduction of the NSE London branch. NSE London UK branch was inaugurated in 2018, the first of 4 of such branches to be established outside Nigeria. One of our many aims in NSE London is to share the engineering knowledge and experience acquired by those of us in the diaspora with our colleagues back in Nigeria, and to learn from our Nigerian-based colleagues about current and peculiar developments and challenges faced back home, hence the reason why we are running this series of engineering seminars. We have held many seminars since inauguration and carried out many STEM outreach to schools in the UK and in Nigeria so that we can encourage more students to study engineering when they grow up. For our country to develop economically, we need engineers like us to keep flying the flags and putting our best to develop the country forward. Engineer Bosun, can I kindly ask you to go through the 4 slides of the NSE London branch, please?
Okay, thank you very much. Good afternoon, honorable engineers. I am Theo Olatubosun-Odunlami, and I'm one of the facilitators and supporters of this wonderful organization. And as my colleague Solomon has just reiterated, the NSE London UK branch has been able to hit the ground running. And our mission statements are just based on the fact that we look forward to contributing to the development of a supportive and vibrant engineering community within Nigeria, outside of Nigeria, encompassing every stratum of development and infrastructures. We've been able to connect with the public and private sectors in all our dealings, and even the academia definitely has been more or less our point of contact as well. We've been able to enhance the connectivity between the Nigerian engineers and other key professional groups, including decision makers in the business and public policy areas as well. We intend to promote investment as well in infrastructures that is fit for purpose, and that is the key word, fit for purpose, and improve the sustainability of Nigerian engineering projects. We also strive hard in all our endeavors to build a closer and mutually beneficial link with engineering communities, both here in the UK and in Nigeria. And as we all know, the saying that goes, it says, the road to prosperity is always paved by good engineering solutions. So engineers are thinkers and problem solvers, and we want to cut across that spectrum. Over to you, Solomon.
Thank you very much, Engineer Bosun. At this point, I would like to introduce one of our engineers who has kindly joined us today for this seminar. We have Engineer Mayowa Dalero, MNSE, who is the General Secretary of NSE Buhari, Abuja branch. Please, Engineer, can you say a few words to us, please?
Okay, good afternoon. Thank you, Engineer Solomon, for the introduction. We'll quickly just go through what we do at NSE Buhari branch. As also mentioned, NSE Buhari branch was established or was approved in July 2018. And since then, we started with quite a number of our programs. Interestingly, we have a motto called, our motto is promoting engineering at the grassroots. So we try as much as possible to ensure that engineering around us, we relate with community, our immediate community, to see that we make an impact on them as it relates to engineering. Few of the things we have been doing is partnering with schools, encouraging them by some planned sponsorship of their best brains in registering for their O-levels, that's WAEC, which is one of the things we have ahead of us also to do. We've partnered with them, we've gone to them to train them, to give them career talk and the importance of studying engineering. We've also done quite a number of things in partnership with the engineering companies in our environment. That is what we do. And ahead of us now, we have the inauguration of the newly elected ESCOs with the first female branch chairman, who is Engineer Limat Adediran. That will take place on the 5th of December. And interestingly, we have a topic that is digital economy in the post-COVID era, that focus on the opportunities in the mining and steel mining industry in Nigeria. And we've been able to, through that, reach out to the Ministry of Mines and Steel Development, and both the senior minister and the state minister of state have graciously agreed to even be part of the inauguration. So the main minister will be the distinguished guest of honor, and the keynote speaker will be the Minister of State, Mines and Steel Development. And lastly, as we continue our partnership with the London branch, our next general meeting will be for the month of November, will be on the 12th of November. And there, Dr. Popo-Ola will also be speaking to us on the topic, very interesting topic, affordable housing in Africa, the use of modern methods of construction. It will be a very good one to be part of. And because thanks to COVID-19, even though we hold physical meetings now, we also share it through Zoom. So if you are not in Abuja and you want to join us, you are free to join. We'll share the Zoom ID in due course. Thank you very much. And generally, our monthly meetings hold on the 3rd Thursday of every month, but the one for November will be in the 2nd because of the national AGM, which is in the 3rd week. So that's why we shifted this by a week ahead. Thank you very much, Engineer Solomon.
Thank you very much for that a brief mention of the activities of the Buhari branch of NSE. And we intend to cooperate with you in future webinars as well. For us, we in the UK here, we are celebrating the month of the month of October as the Black History Month. We are all aware of that, and then because it's one of our aspirations and objectives, and at NSE London, for us to integrate with our ethnicity and look at how we can celebrate the Black people amongst us here in the UK and even abroad who have been able to distinguish themselves in their areas of endeavors professionally. And to do this, definitely we want to celebrate, before we go into the business of the day, we want to celebrate some of our profound and leading engineers in diaspora in this second part of the Black History Month. And definitely I want to crave your indulgence to take a couple of minutes to just watch this clip as we celebrate prolific engineers in our diaspora who have been able to make us proud in their areas of specialization. Let's just take a clip of this, please. Over to you, Doc. Thank you for that. And I would definitely believe that you enjoyed that clip. These are people that have standed themselves in their areas of specialization. They cut across all ethnic backgrounds of the Black of the Black origin. And we have been able to cascade them this afternoon to show that definitely we are going places. So the sky is the limit in any area. And we want to use this opportunity to call on all other engineering enthusiasts. I know definitely this particular webinar is not only for engineers. We can see architects in our midst, business leaders. We want us to come together. We want us to come together as a body to see what we can do together. Hence, if you are new to this branch, or maybe you live and work in London, we want to use this opportunity to invite you to come on board, to please register with us as a member of this particular body, NSE London UK. We'll be giving you details at the end of this seminar. And as we said earlier on, the point is for us to see how we can work together, bring up the young ones coming with us. And in support of the Black Lives Matter as well, we want to make sure definitely that we make the Black community proud wherever we are. And I believe definitely we can do that once you work together in synergy and in togetherness. Thank you so much for that. We want to quickly set the ball rolling and go straight into the business of today. Like you know, our speaker for today is Engineer Halimat Adediran. Engineer Halimat Adediran happens to be the chairman of the Buhari branch of Abuja, NSE. And we'll be getting a very wonderful flavor from her very soon by the time we engage with her in other webinars just to come in the near future. Just to give you a brief history about Engineer Halimat, who is more or less kind of joining with us on behalf of Buhari branch today. Engineer Halimat SC Adediran, FNSC, FNI MEC-E, and FIMC, happens to be the chairman of NSE Buhari branch. She graduated with upper class degree honors in mechanical engineering from the prestigious Lagos State University. And she holds a master's degree in business administration from the Ladoke Akintola University of Technology. She started her engineering career, as it were, with the Central Bank of Nigeria, CBN, in the year 2002 as an assistant maintenance manager. 2 years later, she got a diploma in computer sciences, engineering, and maintenance from Microcrad Institute of Technologies. And she has really, from then on, accomplished a lot of lofty heights in her respected profession, whereby with over 20 years of mechanical experience in various fields of engineering, she has been able to look at how she can improve the mettle of the downstream operation in oil and gas, building services, and so on. She joined the CFAO in 2006, CFAO Group in 2006 as the branch manager, and she rose from there to the position of the regional manager for CFAO Equipment Nigeria Limited. For those of us who know CFAO in Nigeria, those are the key players, the big guys in those days in production of equipment. That position she held on the 2019. At the moment, Engineer Halimat happens to be the managing partner for Doiso Synergy Nigeria Limited, and our engineering and administrative capabilities have earned her so many awards with professional bodies. She's widely traveled. She has delivered several papers and attended many professional conferences, both local and international, mainly in West Africa, America, Europe, and Asia. She has enjoyed an illustrious experience in her field as a mechanical engineer, and has taken leadership roles in many areas that has given us so many awards. And as at the time of putting this bio together, we've been able to count about 24 awards for Engineer Halimat Adediran. So I wouldn't want to get you started on all the awards that she has attained so far in her career, but for the meantime, because of time, so far we're able to count 24 awards that she has got in her professional endeavor as an engineer. That is wonderful for an industrial Nigerian, for that matter. And we want to use this opportunity to welcome Engineer Halimat to this webinar. And I want her to more or less kind of introduce herself once again shortly, and then give us a flavor of what we have for today. Over to you, Engineer Halimat Adediran.
Thank you so much, Engineer Bosu, for that beautiful introduction. However, I am not the speaker of today. It's our own engineer, Dr. Popo-Ola, that is the speaker. However, I want to say that this joint webinar is apt, you know, leveraging on, sharing knowledge with our engineers in the diaspora cannot be ever emphasized. You know, Nigeria needs all the support.
Apologies for the loss of transmission there.
You can get at this point of the Nigerian Society of Engineers. Yes, and it affords us a great pleasure to collaborate with you, and going forward, I see us having more of this kind of collaboration, in various aspects that can further develop capacity for our engineers back home. Having said that, I have the privilege and honor to take the citation of our speaker for today, in the person of Engineer Popo-Ola. The chairman, distinguished members in the House, permit me to stand on the existing protocol already well established as I take the citation of Engineer Popo-Ola. Engineer Dr. Popo-Ola graduated from the University of Leeds in the early 1980s with a combined first-class degree in civil engineering with architecture. After a couple of undergraduate summer vacation placement with Over Europe office in London, Engineer Sunday decided to join a small consulting engineering firm called Alan Baxter and Associates, ABA, where he worked on projects ranging from engineering firm, ranging from £50,000 to £50 million. Engineer Dr. Popo-Ola joined the research team at Imperial College London in 1991 to work on an industrial-sponsored research project titled Steel Intensive Recladding, the subject to which he later achieved his PhD in 1995. His works was relevant to finding solutions to prevent the recent fire on Greenfield Tower. Engineer Sunday specialized in cold form steel, modular construction, and overcladding of building and affordable housing, on which he has co-authored over 150 reports and papers and 5 technical books. He has worked to develop the appropriate guidelines on the use of cold formed steel and the light steel framing and modular construction systems. The ability to liaise across different sections of the department is another indicator of Engineer Dr. Popo-Ola's interpersonal skill. Engineer Dr. Popo-Ola has acquired and successfully researched projects to the sum of £2.5 million in the last 5 years. Contributions to teaching include small group laboratory sessions as well as classroom teaching in competing for first, second, and third year undergraduates. He also researched the creative design models to the first and second year students and consultonium to the second year students, to which he won the Imperial College Award for Teaching Excellence in Engineering Education in 2007. He's where the third year student built 1 in 10 scale models of Greek reversing oil rig platform and Naples Airport canopy. Engineer Dr. Popo-Ola was awarded the Imperial College London Presidential Award for Social Engagement in 2018. Distinguished members in the House, join me as I present to you this ever dynamic, very articulate, erudite engineer, Engineer Dr. Popo-Ola, MNSE, as he presents his paper to us today. A round of applause for him, please.
Thank you very much, Engineer Alimanta Dediran. That script that you described there, I'm not too sure. I keep looking behind me to see where somebody else standing behind me, but thank you very much for that. It's a pleasure to be able to come together as two very powerful branch, one in Abuja, which is the capital of Nigeria, and then one in London, which is the capital of the UK. So you see the two capitals coming together to really synergize and work together. So today I'm going to be taking you through something I've been doing for the last 25 years. And it's a very interesting thing that could be applicable to Nigeria. The student you see on this first slide here, the title is to start with, Modular Construction for Residential and High-Rise Buildings using what we call the modern method of construction. So the student you see here are my students. They're second-year undergraduate students. They go to site on Sunday, familiar themselves with the site and the material and all their risk assessment. By Friday, they're building things. So each team are given something to build. This is a footbridge, about 15 meters long. So you could see there, they were happy that the bridge is standing up and they're able to stand on it. And that's what I call engineering. Not using W²/8 or all those differential equations that we don't know what their application is. They've gone to site and they've done the risk analysis, they've done this health and safety, they've done material composition, they mix the concrete themselves, they set everything up themselves and they build it. So today's conversation, as I've said, is gonna be on modular construction in residential and high-rise building using modern method of construction. And I'm gonna be taking you through a series of items. So these are the contents of what I'm going to be talking about today. And I'm going to introduce you, I'm going to look at the complexity behind it, the design, the market for it, the type of module that we use, the application in residential, which is the title, cost and time, which is a big thing that we all worry about these days, and the benefit. Why is modern method of construction? What's the benefit behind it in terms of economic and as well as sustainability? And before we got to this, we did a series of testing. So I'm going to be showing you some of the testing that we've done. And then look at the application of it in high-rise, which is even more substantial than the residential one. And then the role of building information modeling, which is the latest thing in town at the moment. How does that apply to MMC? And as I've said, everything I've shown here, we don't just talk the talk, we walk the walk. So I'm going to show you 3 or 4 case studies of where we've applied MMC to the work we've done. And then take you on a journey of where do we need to see this in future? How does MMC needs to grow to make sure that we all benefit from it? So take, for example, you want to buy a car. Actually, MMC is not new. It's been used in other industry like aeronautic industry and automobile industry. You want to buy a car, you don't go to Makola market to buy the tire, and you don't go to Computer Big Village to buy the dashboard. You go into the car show, you test it, you test drive it, and it's good. If it's what you want, you drive it away, and that's your car, okay? Why can't we get construction industry into the same way? Why can't we put a factory, build up a factory and put all our module, all our room, kitchen, everything into the factory, and then transport it to site, and by the time you know, a whole building is ready to go. Yeah, so that's what modern method of construction is all about. We more or less transfer it from other engineering profession. So this is what I'm talking about. You come into the factory with all your raw materials. Normally, our raw materials go onto site. We bring them into the factory, and we do things to them. We cut them up. We put them into 2D panels, whatever. This is a typical for a housing. And then we change them into a 3D modules. And then they go on the back of the lorry. I don't like that word, but that's the word we use. Back of the lorry. And by the time you know the building's been arranged on site. Yeah. And if the site is not ready, you could actually store it up in a place for a while. And then, you know, just in time, transport to site. So that's what the technology is all about. And it all started many, many years ago, 1998, when the UK government said to themselves, wait a minute, engineering and construction has been around for so long, but nothing have changed. We're still mixing mortar and block on site. We're still doing all this wet constructions, why can't we look at rethinking construction? And an elderly man called Sir John Egan was commissioned, and he set up a team. I did a lot of work for that team also to look at the rethinking construction. And some of the things they come up with is, let's look at off-site manufacturing. Let's learn from the automobile, learn from the aeronautic industry, and see how we could put that into construction industry. So high level of prefabrication, fast to install, high quality of off-site control, reduce resources and waste, economy due to efficiency in the manufacturing, and then take capture of this economic of scale. You have a factory that is building 50 cars, the same factory could be building 10,000 cars. You don't need anything more than that. You just need to work harder, spend more time, employ more people. Yeah, so that's what the basis of modern method of construction started on that report. And it has a wide application in so many places: airport, school, hotel, hospital, museum, social housing, kiosks, as you see on this picture here, community center, even temporary building. Modern method and modular have application in that. So what's the design behind it? And what is the complexity? Why is it so important that we must move into a modern method of construction? Design-wise, the size of the component is very important. When you're doing a weight on site, as soon as the architect gives you the drawing, you don't worry about the design, about the size. You build whatever the architect gives you to do. With modern method of modular, you have to worry about the size of those components to make sure they fit in the factory, they fit on the lorry, and they have access to site. The weight is also very important because you're going to transport this thing on the lorry. So you have to make sure it's not too heavy for that, and also for the lifting crane that's going to locate it. Accuracy is most important. I will show you a case study later on where accuracy tolerance was not considered properly, and the building have to stop after going to about 10, 15 stories. They have to stop and take everything down and start again. Time for erection, you have to plan that to make sure the foundation is ready before the module starts to arrive on site. The connection between the modules and between the module and the core that's going to take all the lateral load. Health and safety, amazing. In this kind of construction, we have a lot of free edge working at height, and health and safety and all other health and safety, is very important. One life loss is important to construction industry. And we have a very good health and safety record in the UK based on all this extra work that has been done. And looking at environment, it's all about environment these days. It's all about sustainability. So to reduce our carbon footprint, again, this is something you can achieve in a factory than on site. Stability, temporary support, the services that you need to put into these modules. Again, these are all the things we're going to be talking about today. Right. Complexity. You could see the building there. It looked like one of those ghetto buildings in our local village somewhere, or even in Brazil and Mexico. All these buildings that have no order, no shape, and they just put them together, boom, boom, and they're functional. But this one there, although it looks ghetto-ish, but believe me, it's very, very functional. It works. And that's all modular blocks being arranged in such a nice, fancy, complex way, and everybody is able to get into their building. And that simplifies it. This is where modular comes into here. You have a market for port design or to construct a port. That's a typical port very close to a park, not far from me here. And behind me on my screen here, you could see a typical port that I built in my village. That little shed you see there with bamboo and all that, I helped to construct that in my village, and there's many of it. So we construct one, we just multiply. If you look further, you will see quite a few more that's, lying around. So you take a pod, look at the design of it. How much is it going to cost? How long is it going to take to design it? How are we going to get it onto site? And who is going to use it or reuse it? After this one is used as like a cafe that you could stop in the park and get a drink or get a little sandwich, whatever. But after that, can that be used somewhere else? So these are all the things you need to consider. So that's just a little introduction to the complexity of the design using modular construction. And why modular? Why can't we do things the way we're doing things before? Why can't we, you know, as Einstein said that, you know, people are insane if they keep doing the same thing and expect a change. You know, we cannot continue to do the same thing. Things are moving on. So what's the market? What prompts manufacturers or contractors to want to go into the system of using MMC? And these are some of the players in the UK at the moment. Sorry, that one is wrong. It should be Fusion. These are some of the players, you know, Porto Cabin, Yocon, Caledonia, Element Europe, Roll Along, Future Home, and Future Form and Fusion. They realize there's a niche market in student accommodation, in hotels, in apartments. This is a big, massive apartment here, which I'll show you a bit more about it later. And they decide based on that to say, yes, there's a market. They set up a factory. They even convert some old factory used for other things into modular factory. And believe me, they're doing very, very well. And this thing needs to be formed properly. Yeah, what are the type of forms that we have for this? What type of module that we use in this profession, in this module? We have a four-sided module where the panels are created as you can see, a four-sided panel. Yeah, that's the side, left, right, top, and bottom. And then you have a column in the corner that connects it together. You could actually transfer all of this to site and then assemble to inside if you want. Yeah, or you could have a staircase module, which is done again in the factory and transport to site. Or you could have a complete module, which, you know, it's all been completed in the factory with a load-bearing walls and load-bearing columns and beam. And then you could have specialized module for balconies and things like that. I will show you a bit more about it as we go. So this is a typical light steel, as we call it. The modular is made of light steel. The one I'm describing about is made of light steel. There's many, many other modular made of timber, made of lightweight concrete, so many out there. But this one is light steel. And in this light steel, they used to use them just for purlins, roof purlins in 30, 40 years ago. They have no other application for them. And then they realized, wait a minute, these guys are so strong, they're so reliable, they're durable, we could use them for other things. So this particular one here, these are two rooms here. There's a room here, there's a corridor in between them, there's another room there. So incorporate your corridor into the same module. And this is just a skeleton of it. By the time it leaves the factory, it will have been clad with all the things, the inside will have been covered up and all the services, everything will have done in there. So this is just a close-up pictures of how it's all put together with the bracing to make sure it's working properly. One of the things that people say in modular or MMC is that it's a bit of a waste of material, because you could see here, this is a corner of a module here, which has got its floor, yeah, and it will have its roof panel, and it's got its wall to the external, and then a wall to the next module. And then you have another module here, which has got its own wall again. Although in a traditional method, you will not have two words putting together. It will be just one single word. But believe me, the cost of that is far outweigh the advantage that you get from it. Yeah, sorry, the advantage you get from it is far outweigh the cost and the material you've used. Because with this, it helps you to improve the sound insulation between the rooms, between the floors, the loss of heat into the external, as well as vibration. So you can imagine people having a party here and you only have this one level here. The people below will feel the vibration. So these are all the advantage of such system. And you have modules where it's got corners. So this guy here, they just have infill panels. They actually structurally, they're doing nothing. They're just there to fill the space and demarcate the space from this one to the next one. So the working guys there are the column, the beam, and the brace member, just like a box. And they're doing their work to make sure that I'm sure, like all of you know, when you have a window or a rectangular pane, if you don't put the bracing in between, I don't know if you could see this. If you don't put in bracing in between, it won't transfer the load properly, and it won't be effective. So that's that there. And then you have some of them where you need to create bigger room, so you can't have any wall on the side. So assuming this is a classroom and you have 3 of these together, so the one in the middle will not have any walls in between because you want it to be open to the next one. So you could have that too, but the design of this thing is very, very important. And then you have some where you incorporate the staircase. Staircase are very, very funny elements in modular construction. It's not something you just put the mold, the timber mold, and you cast the staircase on site. You have to really, really, really plan this, because the next module is coming on top, and it's got its own floor as well, and this has got its roof. So the treads and the riser of the staircase needs to be planned to make sure they don't clash at that level. Right, let's move on to application in residential. This is amazing. This started many years ago by a group of commercial or housing association called Peabody Trust. They came to us and said, listen, there's a lot of demand for housing in London or in the UK generally, but the rate of building is not fast enough. How can we deliver this? And then based on Egan's report I showed you earlier, they put factory together with Yorkon, that's the factory manufacturer at the time. Peabody are just the housing association. They provide housing for low-income people and all kinds of things. So they put the money where their mouth is, and we created this apartment very close to central London, in a place called Angel, for those of you that knows London very well. And we're trying to maximize all the recommendation in Egan's report. And when we started, we put cladding on the module. And as we were transporting the module, the cladding were falling off, because the cladding were not really fixed cladding. They're what they call is brick slips. They just slip into the tray that's attached to the side of the. So all those lines you see there, those are the tray that the brick slip needs to attach to. So they were falling off. So we said, listen, instead of wasting time and picking up brick slips as we go along, let's just transport the module bare like that, and then on site we put the cladding on. So the quick solution to a problem that was not envisaged before. And this is the inside of it. So you're looking inside, you will not, definitely won't think these are made of these boxes attached to each other. It's beautiful inside. And that set up a lot of people say, wow, if you can achieve this, then we need to work a bit harder and achieve more. Then you have the timber people also coming along and do their own thing. So this is a typical 3-bedroom house, yeah? And all you need is 3 modules. There's one module here which incorporate the balcony to it, yeah? And also another module here which incorporate the kitchen and the bathroom, or storeroom, bathroom there. And then the last module here, again, another bedroom and the toilets and baths. So everything could be incorporated within the module, and they just come onto site and fit it together. And obviously you have a door flowing through all the 3 modules. And then with that, you go up and start applying it. So this is a company called Unite. They got to realize there's a niche for student accommodation. Amazing niche for it. I don't know about now that we have Corona with us. Yeah, most students are working from home now. So they saw that and they start building student accommodation everywhere. The big thing about Unite, they're not just manufacturing the module, they also have a contracting arm of their company. So they manufacture the module and then pass on to their own contractor to build the building. This is about 12-story student accommodation. This is the one I showed you earlier. It's called Paragon. We did a lot of fantastic work here. This was done by a company in Ireland, the modular company in Ireland. They put this project together, and you could see the concrete core already on site, rise, boom, 12, 13 stories. Before the module starts to arrive, the concrete core is already there. And this is a typical plan for that particular building there. And you could just see the line of the modules right here. Yeah, that's the lines of the module here, where all those lines are, that's the modules right there. And these are the modules which incorporate the corridor, one room on the right, one room on the left, and then the corridor in between. And this is typical of the module being lifted onto site. You could see, I think I showed the skeleton of this module earlier. Now it's being, the window is being put on, some of the facade element is being put on, and it's being lifted. And lifting also is very important. You have to think of the wind load and the rain and all kinds of things going on to the side before you lift. And you have to make sure you lift in such a way that the module is not going to get damaged. So you can see this one, it's got 8-point lifting point on this module to make sure it keeps it flat and lifting very equally. And who says modular construction is just boxes? This is a house, a private house somewhere in Arlo, in West London. And although it comes in boxes, as you could see it here, by the time it finishes, amazing, amazing, good looking with a nice car, and nobody will be able to tell that this is made of those boxes. And then you have some more where you have what I call a plug and play. These I always argue with architects and engineers that it's a little bit of waste of materials there. You have your steel structures already in there, and you just bring your module and plug them in. Yeah, plug and play. It's an experimental design that we tried. It worked, but I think not many people have tried that for a while now because of this double handling of materials there. You have a steel there, you have a column, you have a beam, and then you have the same thing on the module itself. And then application in school. This is a big thing because in the year 2005 to 2010, the UK government decided to rebuild all secondary schools and then build new one they call the academic colleges. You know, it's like technical school in Nigeria. And to be able to build them fast and efficient, they have to use this method. So a lot of these schools we worked on are using modern method, they're using prefabrication, they are using modular method. And some of these schools, they could go up within a week because everything is done on offsite. And you just come to site and attach them together. And while they're building offsite, the foundation is being prepared. And the foundation also is very, very little. It's not very big at all. And then you have other application where this is East London, where the ground floor is made of steel structures. And then the modules are assembled on top of it. These structures there, these two structures there is a lift core or staircase to resist wind load. Otherwise, the module transfer their own load vertically onto the foundation. But the ground floor, you see there, they use them for all kinds of commercial activities. There could be a store there, there could be a shop, there could be a laundry, there could be all kinds of things in there. And majority of them get occupied well in advance before the module is finished. Because once they've done that, it's quite safe, you put all your gantry system into place and the module continue to go on top. This is a developer. Again, we work with this guy. It was all the way from Poland. It was trying to get into because he saw there's a niche in the British market for modular, and he developed the system back in Poland, and they put them on the barge all the way to London and erect this in 2 weeks. 2 weeks. It's about, I think it's about 12 or so flats in this apartment. Within 2 weeks, everything was done. You could see the balcony also is incorporated into the module. And then you have other applications where people are looking for extra space. A modular construction, modular method is the best way to add new module onto the top of your building, provided the existing foundation and the connection and the roof is strong enough to take this extra but very light load on top. So this is an extension to a building in Plymouth that we did. And as I've said before, who says modular is boring or modern method of construction is boring? Can you tell me from that shape, from that curved roof there, that the whole thing here is made of boxes and rectangular shaped structures? You cannot look at that and tell me that. So you can't have, and you do have different shapes or forms of building. This next slide is a company called Element Europe. And if you guys use London Bridge Station, this hotel is very close to London Bridge. And you're sitting inside there, you think you're in space. You think you're in a spacecraft. So how subtle, how comfortable the old space is. And looking at it from outside again, you will not see. The ground floor is made of bars and restaurant and all that. And then you could go up and enjoy yourself in your own room. Okay? And again, more of these plug and play, as I said to you earlier, where the kitchen as well as the bathroom module, they come in 3D. Everything else come in 2D panels and assemble on site. So some people that, especially when the site constraint is so bad that you can't get a big lorry onto the site. So you bring the members in 2D panels and quickly put them together. But the smaller module, which are not as big, the kitchen and the toilet, they could come in 3D module. And each time you get to the floor area, you put the next one on. You do the floor area, you put the next one on. So again, it's a quick way of building something using this method. And this is what is finished at the end. This is the same building there, and this is what it looks like when it's finished. And again, in apartments, the same thing. You could either have a module put together, or you could have a 2D panel put together. But when you're looking at them at the end, you think these things are done by traditional methods. And they go up so fast, you won't believe it. You see the land one day with nothing, within a week or two, the whole building is done. And people thought, what's going on there? Is this magic or what? But that's it. That's what we're doing at the moment. And I told you earlier, the use of material is very important in these things, because these materials are very tiny thickness. These are 1 millimeter, 2 millimeter, 1.6 millimeter there in the floor system. And then you have another one which are 2 millimeters. They're very thin compared to thick concrete or thick timber, 2 inches, 3-inch timber. And the way you connect them together, it makes them look so efficient. They work very, very, very well. And this is the same building I showed you earlier, just to show how the ground floor is made of ultra steel section and then the module on top. This particular one was done in Manchester. This is a student accommodation. It was massive. It's like a rectangular shape, and it's got a big courtyard in the middle. So this module here, you see it just on the edge of the triangular shape. And again, you could see a concrete podium here that's already gone up, and they're ready to start putting all the cladding on top of it while the module is being stacked on top of each other. This is the architectural impression of it when it was finished. You could see the ground floor full of all the commercial activities. And right here at Imperial College, we make use of this as well. This is one of our buildings here where they want to put the service room, or I think it's a service room. There's no space on the ground to put it. Even this staircase module here, they all came in as prefabricated, and then the crane come and locate them. Sometimes when you can't put the new building directly above, you have to create parts for it to go on the column. So there's a beam here supporting this box here, and you could see how this directed towards the column so that the load will go straight to the column, which is basically what this drawing here is showing here. Yeah, and then many more companies came along. MedSec, again, they saw a opportunity in student accommodation, and they built some beautiful student accommodation out of modular. Right, how much does it cost? Well, I mean, I've described some timing and things like that with you just now, but time and cost is very important to construction. So we need to review this, and it's not just cost, it's a whole life cost. Modular construction is so fantastic that there is hardly any callback within a year or two. Most traditional building, within 6 months, something is leaking, a pipe is busted or something happened and they have to come back. With modular, everything is tested on off-site to make sure it's all working. So this is a typical chart showing all the costs involved, comparing the site intensive, in other words, traditional with modular construction. You could see this yellow part here. On site, that's a site preparation personnel cost in terms of labor, and look at what you have when you come to factory. Although some of those transfer into factory overheads, yeah, and you have other factory personnel costs which you don't get in the traditional method. But look at the percentage cut in material and waste from 30% to 20%, and also transportation. Yeah, transportation is now only 5%. So instead of transporting all those material in bits and bits, cement bags, sand, and all that, everything is cut down because you're able to do all of that in the factory. Now, let's look at the economic and sustainable benefit of modern method of construction. Some of these figures I'm going to be giving you here, these are now just popped out of the air. We've done a lot of research over time to come up with these figures. Speed of construction, you can't beat it. As I've said to you earlier, before the building is finished, people are already occupying it. You're already cutting down on instead of a 2 years program, you cut it down to 6 months, and you've got 18 months of rent already going on as soon as it's finished. Yeah, so you reduce your construction time quite a lot. Management and facility cost is also reduced. Quality goes up fantastically. Economic of scale, as I said to you, if you have a niche market and you know you can produce 500 instead of 50 module, go for it. Economic of scale works in your favor, and it improves productivity and installation. So you have to train your workmen to be able to do this very well. And this is just a typical construction timeline that we normally use. I mean, I haven't put proper dates or anything on it, but as the foundation is going on, the module is already working in the factory. And the module comes on to site, and then immediately the module is being positioned, the cladding goes on. The finishes, if there's any extra finish you have to do, that could be done while all of this is going on. And then your external work and fit out. And as a result of that, your speed of construction goes up, you reduce the site waste, you improve quality, and module can also be reused. If you think, oh, I'm fed up with this module, you could replace it, because the way they are put together, they can be disconnected and another module put in place. And this is just a summary of some of the research that we carried out. I'm not going to mention all of this, but look at embodied energy, the reduction in embodied energy, something that's contribute to all our ozone layer. You've reduced that. Site waste by 90%. But the most important for me is safety. Safety reduced by 5 times compared to safety on site. And site production also increased by 4 times. So you can't compare any otherwise. This is a project in Sweden that we did a lot of analysis on, as the building has been fabricated in the factory and on site, and all of these numbers that you see here, we actually measure them, and we know that yes, this is what we got. Site waste reduced by 90%, embodied energy by 20%. Right, before all this started, it's not like we do in some country where you just go along and throw an arrow and all that. We did a lot of testing. We did a lot of research, a lot of testing to make sure this system will work. And then we set up a body that will satisfy all the new system coming to the market, that will check them, test them to make sure they will work. So we don't want to put a system out there and then within 6 months you find that it collapses because it hasn't been checked properly and it hasn't been tested. And myself and many other people at Imperial College, we did a lot of testing for this company to check the buckling capacity of these members, the spanning capability of this member, and the connections of this member. I published so many books, I haven't got any in front of me at the moment, that tells you how these buildings are put together, the capacity of all the members that's being used, depending on their thickness, and how you could put them together. So we did all of that, and that resulted in a lot of publication, both in the strength of this material, the durability of it, and the way you put them together. So this is a building here showing, or tester building showing the connections on the ground, which is all going to be covered up. Afterwards, you won't see it. And then we did a prototype. Again, these are 2D testing here. Yeah, plain 2D dimension testing. We said, okay, let's put it all together. Let's see how the whole thing operates when it comes together. So this is a skeleton of a building. Floor, everything is there. We put some concrete blocks to simulate the roof load. And then on the floor, we'll put water tank. And then this H frame or A frame you see there, this is a frame that has got jacks on each level that will apply what we call the wind load or the side load onto the building. And these were all done and tested for over 6 months. Yeah, and after that, we thought, okay, fine, it works. And the bit that doesn't work, we improve it. And then Oxford Brook University commissioned us to build one of those buildings as a prototype on their campus. So one side of it is the chancellor, and the other side is a student living in there. And believe me, I've seen building being monitored. I've never seen anything like this. Everything's been there. Floor installation, stand installation, you name it. We have it on this building here, and it's still there working and doing very well. Here I was going to show you some of my publications of with many publications into the strength of the material, the calculation you need to find out how to design this thing. I have about 15 or so publications. I was going to show you some phases of it, but I didn't get a chance to do that. So there's a lot of information in this thing. We're not just talking by looking at it alone. And as you know, traditional method, the moment it rains, it's raining in London as I speak, and the moment the snow comes down in Europe, everything stops. Not on modular site. Modular site, everything continue to go. Yeah, because you don't need much, things done on site. The module come on site, and when you get your slot, it stop raining, you put your module on, and then you relax and go for your cup of tea until the next slot comes along. And this is a typical building, school building that I have to construct in South Korea. The reason why I showed this slide, you could see the foundation there, the module coming on site, but you could see air, that's a pond of water air. One of the specifications we gave them is that every time they finish erecting maybe the ground floor or whatever, and they go home, they should cover the building up. You can see that that's a cover for the roof and the cover. On this particular day, they didn't cover it up. And they called me on 3 o'clock in the morning and said, Dr. Popo-Ola, we have a problem on site. I said, what's your problem? It's raining. And Korea have monsoon rain. When it starts to pour, it really pours. So that teaches them a lesson. They were very lucky. Air conditioning, light, they were not too damaged, but they were able to rescue it. So you should always follow specification. Now let's move on to high-rise. This is where the challenge really coming for modern method of construction, or should I say modular construction. This is a building in Wolverhampton. It was the tallest for many years, 25-story, 825 module, and everything was put together in 6 months. Yeah, can you imagine trying to construct that out of traditional method in 6 months? Yeah, impossible. And then erect everything in 12 months on site. And these are just some of the statistics of how much safety, how much saving that incur because of these things. And it costs 37 million naira and pounds. That's about what one senator earns in Nigeria, isn't it? Yeah, 37 million pounds. Yeah, can you imagine all senators, using their salary for the year to build one of these? The country will be beautiful. Right, this is just some of the elements and connections and lifting and all that of this building. The core goes up much faster before the module starts to arrive on site, and this is what it looks like when it's finished. And then we have other companies. It was the tallest for a while, from 2009 to about 2012, whatever. And then other building comes along. This is another one by Unite, the company I told you earlier, that they have a modular factory as well as a contracting firm. So this is one of their student accommodation near Wembley Stadium, very close. From here, students could watch football for free if you're standing on top here every weekend. Yeah. And then we have this one in New York. This is the one I said to you that if, when the tolerance is not done properly, it could cause problem. This building started, it was 32, the other one was 27, 25, and this is 32-story. When it started, they had to stop because they found that as they're going up, the building starts to misalign. They were not able to connect the modules anymore because there's not enough tolerance within the joints. So but now it's completed. I don't know whether it belongs to President Trump or not, but it's not completed and it's not being used. Yes, and then you have another one in Wembley. Again, I don't know if anybody's been to a restaurant called Mama Calabar in Wembley. Those of you that live in London. This is the site of Mama Calabar. Mama Calabar used to be on the 3rd floor of the old building, and we used to have some good egusi and ogbono soup in them for many, many years. Now it's been taken down, and they've put apartments, student accommodation, you name it, in there. A 29-story built in 16 weeks and construction in 11 weeks. There's no way you get a traditional method to achieve that. And typical floor system of that is there. Easy access from the core into each flat or each room. And as I showed you earlier, this is a typical 2-bedroom house with 3 modules. So you have your living room in one and your kitchen. You have your bedroom 1 with the bathroom, toilet, and bedroom 2, and incorporated corridor, balconies. Yeah. Okay. And this is a 2-module version of the same thing. This particular one is an amazing space building, very close to where I live in North London. All the ground floor apartment, they call them home office. Yeah, when you say a home office to somebody, they start to run, but they call them home office simply because they have 2 separate areas where you could do your office work during the day, and then you cross across to go to your home environment. So we call it home office. So there's a clear demarcation. And guess what? A lot of people that living there now having a benefit of it now that Corona is locking all of our home to do our work. So they could still go to office because their office is right there and their home is just across the corner. Whenever I take visitors from other countries to this apartment, there's a lady here that always allows me to come in so that I'm not just doing the talking. I'm actually showing them the demarcation between the home office and between the home and the office. And then we have other facilities where you have what we call the hybrid, the module and the frame. I think I showed you that earlier. Again, I think there's too much double handling here, but for some reason, these are designed for people that want to take their module out and locate somewhere else. Yeah, and another person. So if you're fed up of living in London because the tax is too high or the transport system costly, you want to move to Birmingham, you could take your module away without destroying the structures of the building and go and plug it somewhere else. And this is what those modules look like. They have a corner section like this that are attached to the column on those frames. Yeah, and again, they can be clad anyhow. They could have a traditional brick clad, or they could have a metallic modern brick clad. And this is the application of a typical metallic clad for an office somewhere in Wales. I think this one was. And looking at that, you will not think they're made of modules. Yeah, and as I've said earlier, I'm just emphasize again, this thing shows you double walls and double floor, but believe me, it is worth it. And it's actually very efficient and it's safe cost as well. Yeah, and again, another corners. This is the problem the New York building had. They didn't have enough location holes in the corners, enough tolerance for the bolts. So that, you know, as you're building up, you get to 10 floors, you're definitely going to get some sway in alignment. So if your hole is big enough, you should be able to still be able to put your nuts and your screws in it. But they didn't do that. And the staircase, as I've said to you before, yes, we have this issue where the floor of one module and the roof and the ceiling of another needs to come together to form that step right there. And if it's not done properly, you will not get that to work. So a lot of people get caught in there to the extent they have to then build another step because the structures is now done properly. Right, building information modeling. I'm sure you've all heard of this, and I hope Nigeria is also turning into this. It's well used in the UK and Europe, whereby everybody, and I mean everybody, architects, engineers, detailers, fabricators, contractor, project manager, comes together and they work jointly. They're all reading from the same drawing, and there's going to be any clash in anything, they can see it before they even start work on site. So this is what, for me, has a fantastic application in modular construction. Yeah. So we've been using that to design some of the things we do to synergize between all the professionals. But the market for BIM is so massive. It's just amazing. Everybody want to get into it. Every small company and big company. The leaders in this is Autodesk, and there's so many other ones as well that are creating software, they're creating methods in which you can combine all of these things together. My problem with them, which I always say to them, you guys need to sit together and come up, there's a code that they all have to compile with, but still some of their software are not compatible with each other. So how will I be able to work with a different person that's using a different software if I can't transfer my file together easily? So this is something they need to take account of. Right, I'm almost there. This is going on to the case studies now. I'm going to go through this very quickly. Apart from the Moral Grove house I showed you earlier, where the cladding was taken off because it was falling off, this is one of the first building we built. And apart from the Oxfordbrook one, this is actually dated well before the Oxfordbrook one, where we did a module. There's a factory not far from the start of this building, and we erected this building one weekend. This is a 3-bedroom house, one weekend. And I mean, they started serving food and people were sleeping in it after one weekend, right? So it's just to show you how quickly this thing goes up. And this is the one in Korea, which I again mentioned to you. Korea is very interesting. Korea is like Nigeria. Things that can be very slow, and a bit of corruption as well is involved. I wasn't part of it, but I know I could see it. And this is a school located where the population is growing. People need more school space, and there isn't, and they can extend the school building, which is about here. So they came to us, and also the company called POSCO. They're the biggest steel manufacturer in South Korea. They wanted to go into the market of modular construction, and they came to the UK to land. They could have gone to Japan, but we know why that is. They came to UK and they land, and we designed and built a school for them. But before that, we spent about 2 years. This is where correlation with Nigeria comes in. We spent about 2 years talking about it. This guy will come to London, UK. I take them around to places. We go to Korea. We have meetings. This is one of my colleagues here, Professor Mark Lawson. And then the final meeting we had was with the school principal, because she just didn't say it. Why we want to take the football ground and put a building on when we could add a building on top. So we have to convince her, and it takes a lot of people to convince her, but it worked. And what we did, we designed everything in the UK. All the modules were designed in the UK. We have an architect, engineer, myself, and we have each classroom have three modules. 6 classrooms, 3 on the floor, on the ground floor, 3 on the top floor. We have a 2 toilet module, and then we have a 2 staircase module. So everything, the corridor is fitted within the classroom module. And this is what happened when you've done that. They quickly, because Korea had 6 car manufacturing companies. So experience of working in the factory, they're very, very used to it. They know all about it. So we didn't have to teach them anything. So they quickly manufactured this module while the site work was going on. The module, the roof sections in 2D, the module in 3D, cover them up and erect them within I think this was 2 months. 2 months, and we were working weekend as well. So I'm going to show you a quick video of the construction. I'm going to speed this up a bit. So thank you. Oops. Thank you very much for that. And this is the building during construction. But the bit I enjoy very much is when I went back in there and they're telling me, the student, that this is one of the engineers that work on this building. They were all so excited. You see this young boy here? I don't know if you could see my pointer here. There's this young boy here. He ended up coming to Imperial College to study. And the first day he saw me, he was so shy to speak to me. And he was telling other people that he knows me. And then another English student came to me and said, "Oh, sir, this young man said he knows me." I said, "No way, I'm not his father. There's no way he will know me." I'm not. But he then opened up and said, "Yes, I know you." And he described, came to their school, and he even got some of these pictures as well. And he was so pleased to say, after so many years, from 2009 to now coming to Imperial College to study, he was able to link up with the same person. Isn't that amazing? Isn't that wonderful? So for me, that's what wakes me up in the morning, to know that young person like that could gain so much from such thing. Right, so the Korean people, they move on. While we're still trying to convince a lot of people in Europe, they move on. And we have other meetings. Now with the big players, they love their food. They eat very late at night. Look at how fat I am in there. They eat very late at night. By 6 o'clock, 7 o'clock, they're in the office. They don't leave office, only their boss leaves offices. So if your boss is there for 11 o'clock, they'll be there. And I say to them, no, I'm here for a month. I'm not gonna stay in the office for 11. I'll leave the office about 7, 8, and 6 in the morning, I'll be back. So they understand my working schedule. So they move on to do other things. And this is where they put a computer classroom, computer hubs on top of an existing school. Believe me, we didn't have to tell them much about this. They went ahead and did everything themselves. But just in case they've done something wrong, we did a lot of check-ins for them. We did all the calculation checks and all that. And when the building was being erected, they invited us to come and have a look. And I went back again, and you could see how beautiful, how wonderful the students were so pleased to see me again. But the Koreans, I love them, or South Korean, not the North one. Despite doing all of that and trying to get more knowledge in modular, they're thinking that one day South and North Korea will combine. As a result of that, they are building modular housing along the border. They don't care whether North Korea blow them up or not. They're building modular because all those guys in North Korea, when they combine eventually, it's like East and West Berlin becoming German. Yeah, when they combine eventually, they want those people in the North Korea to have the same standard of living as the South Korean. So these houses here, made of modular, they're sitting down there empty, and I've seen them. So these are legacy as far as I see. They're setting a good legacy. This is my latest project, and it's almost finished. This is in Croydon. This is the tallest one in the world now, apart from one coming up in China, which it's not quite completed yet. It's 54-story. I took my student there just before Corona started last year, and it's beautiful. How quickly they went up. Comprises of 546 modules or residents, amazing connections and everything, located very close to the train station. It was a old British race office site that was taken down. And HTA, I've done a lot of work with HTA and Tidal Constructions are the contractor on these. And Vision, which I showed you earlier, Vision Modules, they're the one that manufacture all the modules in their factory in the west coast of England. So that building is already up and is running. And I've got some YouTube here, which will take forever. If the YouTube videos there, we set up a video away from the building for one of those time video, and it records everything that was going on in that building, day and night, how the cladding was going up as the modules were going up, how the final fitting was going up as the modules were going up. I can post it on our chat later on. Actually, I'll post it on the chat now. If you want to have a look at it, you can do. And with that particular building, my involvement, apart from design of the module, is the connections. Because the building is so tall, and also London has been experiencing a few earthquake tremors, we call it. Not real earthquake, but earthquake tremors. They've been experiencing that, and as a result of that, they reckon that they want to have a connection that will make sure that the building does not subject to earthquake, and if it does, it will be able to resist the earthquake. Oh, sorry, I've created some. I wanted to post the link first. Let me just post this link. So any of you that want to have a look at it later on, go have a look. Right. Okay. So my involvement here was this connection, to test the connection, to make sure with a little movement from earthquake, the connection will continue to stay together. It will not slip. We tested about 5 or 6 different grip washers to make sure this connection will stay. And if it does move, you're only going to move within the allowable movement. So that's my involvement. And they were very pleased, because some of the time you don't do things because we've designed over it with too many safety factors. It's never going to happen. We don't know if this is going to happen, but they spend some beautiful money at Imperial College to check this out, to make sure it doesn't happen. So this is the final building. Like you see, is almost completed there. I'm coming to the end now. Right, future trend. With all these things, we have to change. We have to move on. As I said to you earlier, if you keep doing the same thing and you don't check around you and progress, you will never get new results. So you have to think of things you need to do. So in our case, modular trends, future trend. We need to standardize things a bit more. Dimensional, structural zones. Agree that yes, your floor will be this much if you use this much material. The surfaces connection, the cladding type, whether you pre-attach it or you attach it on site, and how high this building are gonna go. What's the limit? There's a lot of tall building. Burj Khalifa, which I was involved with, is the tallest building in the world at the moment. They're thinking of building something higher than that. Where do you stop? You know, how far can you go? You want to reach heaven or what? You know, the use of mixed structural frame and module. And for me, especially Africa, I've been trying to get light steel into Africa for many years now, but nobody's buying it because the material needs to be imported. So if you can have module built of timber, although provided we don't have hurricane as we do in America, that will make everything to go down, or glass, or even spray concrete. You have a 3D modeling things going on now where they can spray concrete or spray steel, 3D printing. So these are all the things that is on the horizon that we need to tap into, we need to start looking at to make sure in 10, 15 years time, our method of construction is much advanced. The aerospace, the aircraft, the automobile are far ahead of construction. So we need to do that. Containers, there's millions of containers all over the world just sitting down there not being used, although our people are converting into their little stores and all that. But you could convert container to a beautiful home. This is a building by Travel Lodge, hotel company called Travel Lodge. They use container, existing container, they join them together and they build hotels out of it. Beautiful. And again, more container being used here, because what's the point? Container come to your country with goods from abroad, you can't fill it to take it back. You might as well just keep it and use it for something else. So this is a good things that we should look at. And as I've said earlier, timber is another area we could look at, provided the building site is not located in Hurricane Field, American Trump. Yeah, you could get all kind of beautiful shapes. That's a room and a roof of a timber house right there going up. And who said modular is boring? Who said modular is not beautiful? I've seen a lot of houses in Lekki and some part of Abuja that look very, very similar to this. And then you ask them, how long did they take them to build it? 2, 3 years. I say, I can build this for you in 3 months. They say, what? I say, yes, I can design this and build this for you in 3 months if you're ready to pay the cost. Yes, it may cost more to start with, to build and all that. But if you look at the whole life cost, modular is far, far outweigh traditional. I can prove it to you. I've done it. My house is built of modular and it's seriously within 6 months done. Yeah. And then we have to look at advanced method of doing things. We have to bring in beam into it. We have to, tag all these materials, all these parts in case you want to erect them and you can't find the material in the middle of all your store. You just click your buttons on your phone. It will tell you where this box is or where this item is, and you'll be able to locate it very easily. And for repair or for maintenance, this is very easy to identify what is going wrong that you need to change over time. So this is the next thing. This is the next IT, the next data connection, the next Internet of Things that you need to do, or we need to start thinking to progress. We don't have to wait for the Western country to do this thing. We can be ahead of them. I was in a seminar, a webinar earlier, and they're talking about Internet of Things. Nigeria and many African countries, they're really, really ahead on this thing. But they need to do it in a much bigger scale. And this is one application of it. And as I've said to you earlier, if you're living in Lagos and you have a module or a 2-bedroom apartment, and you find out that the governor of Lagos or any other governor, they're not taking you very seriously, they can't allow you to breathe, and you wanted to leave Lagos, this is just an example, don't take my word for it, and move to Kaduna or some other liberal or Kwara State, which is where I come from, and want to live there, you could take your pods, you could take your module, you could take your 2-3 bedroom, plug it out of the system, and go to another place and rent a space and plug it back in, and then your life continues. This is a system we developed for London, especially in London and UK. There's something called council tax. And people like to move around because of council tax. Some people even live on a barge just to avoid council tax. So you could do that. You could move your old house from one city and plug into another city, and as long as you want. And then when you finish with that, you could take it out again and go somewhere else. So that, for me, that I could see as a feature in terms of BIM, a kit of parts, plug and play, and these are there of moving around because the world is becoming a single thing now. You could even move my house from here now back to Nigeria. I saw a school building yesterday. Somebody sent me a video on my WhatsApp yesterday. A old school building, 4-story in China. They moved the old school building. They lifted it up on the jack, and the jack walked, and they located it somewhere else. Obviously not far from the existing, because they want to use the site for something bigger, something better. Yeah, so this can be possible. And these are the things we should be looking at as engineer. And hopefully from my 45 minutes or so of talking, or maybe 50 minutes, I believe I've introduced to you modern method of construction. I've explained to you the design behind it, the complexity, the market, what makes people to want to go into this system or use the system, the different type of modules and things that we need to consider in terms of building them, transporting them, and erecting them in terms of weight and all that. I've shown you different applications in residential. I've justified the cost and the time of construction to you. I've demonstrated also the economy and the sustainability benefits of this method of construction. And I've shown you some of the earlier testing we do. We're still doing testing now. As I show you the one on Croydon with the connections and all that. We'll continue to do testing to improve things. And I'll finally also show you the application in high-rise building. I think we need that so badly because everybody wants to build tall these days. Can modular construction help in fast track this? And the use of beams and some of the beautiful case studies. I have far more case studies than that, but I only select the one that I think will be relevant to our country. School building, apartment building, high-rise building, private houses. Those are the ones I show you. But I've got so many other case studies that I've worked on that I could have shared with you. And at the end of today, I've shown you what we need to do to advance this thing, to make sure we are ahead of this. We don't have to wait for the Western country to show us how to move forward. We should be the one that could push this thing further, as we do in banking. Nigeria banking system is amazing. I gave everything on my phone. To get my banking here, I have to log on to my computer or go to the little ATM to find out what's happening. Even go to the branch. Yeah, but Nigeria is so advanced. The moment the money comes in, the money comes out, boom, you get an alert. So for me, thank you very much for listening. This is modern method of construction in the UK and across the world. Thank you very much.
Awesome, awesome. Can we give Dr. Popo-Ola a round of applause? I mean, for those who can unmute themselves, I mean, he deserves that. And thank you very much for that. Thank you.
Congratulations, sir.
Katanga.
Thank you very much. Well done, sir. You have done well, sir. God bless you.
That's awesome.
That was awesome.
Thank you very much.
That's great.
Thanks, Dr. Popo-Ola.
Thank you, Dr. Sunday Popo-Ola.
Thank you, Dr. Ola. Sunday Popo-Ola.
Thank you for that. I have to meet everybody.
Thank you very much for a good presentation.
Thank you very much. Thank you very much. I really appreciate that. I mean, I've got so many questions here, but I can see that most of us would like to have the copies of the slide as has been given to us by Dr. Sunday Popo-Ola there. So what I'm going to do, because I've got so many emails here that I need to put down and send the slides to, what I'm going to do is that I'm going to put our email address will be on the chat section for everyone to copy, and then send us an email, and then we'll be able to reply with the slides as soon as possible. Please, I think that's the best way to do that, because if I decide to take down how many people really want this slide, I might be here till maybe midnight. So if we're going to put our email address there on the chat section, and then send us an email requesting for the slides, and then we will get back to you with the slide. That is the surest and the smartest way to go about it. Dr. Sunday, can you help us with the email address on the chat section, please? And when I go through the question and answer session here as we have them. We are about to rounding up, but I just want to more or less kind of use the opportunity to say thank you to Dr. Sunday Popo-Ola for an insightful webinar that we've just had. And for those of us, my humble self inclusive, that have been involved in multi-dwelling units, MDUs, this is the best way, and this is the cheapest and the fastest and the safest, so to speak, way to go. Because definitely for those of us who are in project management, the risk involved in construction of modular sections and buildings, the risks are far, far lower than normal point of concrete and formwork and everything on site. Yes, that is our email address there, NSE London UK Gmail. Send us an email with your email address, and then we can get back to you. nsclondonuk@gmail.com, and then we will send you the slide. So for those of us in the MDUs, I mean, talking about multi-dwelling unit, this is the best way forward. And you can see from that inside that most of the tall buildings you see in London, they are actually modular elements. And that is what Dr. Popo-Ola has been able to show us today. In my own field at the moment, definitely my company has just won a bid for an MDU at Stoke for network rail. And I've just submitted another program, a works program yesterday for a bid for another one for MTR Elizabeth Line, which is Crossrail. So everyone is going modular. There's no way for you. For hospitals, for barracks, I think definitely the Nigerian police should be looking for ways of getting modular structures for the policemen in their barracks. I'm serious about this. That's exactly the way forward for them. For schools, for health industries, for offices, for banks, it's modular. And I think we need to tap into this technology. It's safe, it's easy, even in built up areas, definitely, it's the best way forward. And I believe it's an eye opener for us to take on board. Now, I've got a couple of questions here, and Dr. Sunday, I hope you are there to kind of take us on that. But first of all, I've got Dr. Moses. Dr. Moses, unmute yourself and ask your question, please. Dr. Moses Yegwena, please.
Okay. Hello, can you hear me?
Yes, I can hear you, Dr. Moses. Go ahead.
Okay, I already did. I don't know where Dr. Sunday gets his enthusiasm from. He's certainly not from Leeds University.
Is that the question, sir?
No, I have my questions. I'm familiar with this technology I've been discussing with Sunday over a number of years.
Right.
I think maybe he can answer this question, why I think it's not being adopted in Nigeria. I'm just thinking, the question I want to ask Sunday is, how would these modular units cope with the kind of roads that we have during the process of transportation, coping with the inertial forces so that you don't have damage or misalignment at the point of assembly?
Okay. Doctor, do you want to answer that? Dr. Popo-Ola? Hello?
It's muted.
It's muted?
Sorry.
Right.
You want me to answer?
You got your...
That's okay. Do you want me to answer that, or do you want me to take a few more questions and I answer them all together?
I think you take that one first, and I will give you a barrage of questions to answer together here, please.
Oh my God. Right. Engineer Moses, as I've showed you earlier, with all these things, we have to test them to make sure the roads, we do a reconnaissance of the road that we're going to go through, and then we'll test them. We always run them first to make sure the module is not going to get damaged during transportation. And if it does, we'll reinforce it a little bit more. Yeah. If I go back to my slides, I should be able to show you a couple of other reinforcement that we've done. Let me see if I could share another slide. Yeah, okay. I will show you a couple of other reinforcement that we did just to make sure the module doesn't get damaged while it's going on site. This was in there. All right, that one there. Can you see this one here? Can you see this column in the middle here? And on the other side, it's not supposed to be there. That's a free space there. But because of transportation and lifting, we have to put that in there temporarily. Yeah? Another can say, oh, you're wasting material. Another. No, it is important that it stays there. Otherwise, the floor could bend. You know, all kinds of things could happen during transportation. So we make sure we do things like that to make sure, even though the road is not good, you design your module to cope with a bad road. Yeah, if necessary. Yeah, because with that, you make sure you're reducing the damage that you're going to get at the end of the day.
No, you've answered my question. I just want to be sure that we take account of the peculiarity of the Nigerian environment.
Yeah, and this
that may eventually push up the cost.
Yes, indeed. Like this one, yeah, we even cover it up in case of rain as we're in transporting. And then you make sure the gantry system that the lifting beam is parallel to the module. Yeah, instead of lifting at an angle for some modules which are very long, you lift them straight. So there's no bending in the module. You could see this was actually designed just for this module. So it's lifting vertically. Yeah, and the whole thing is not bending.
Thank you for the answer. I think it's fine because I just want to be sure that we understand, because this is a technology that is familiar in the oil and gas, that when you lift, you preclude bending. But at least for Nigeria, we are aware that if this technology is to be adopted, there are additional engineering considerations that are maybe peculiar to the, not unique to the onshore industry. Thank you.
Yes, yes.
Thank you very much for that. And Dr. Sunday, I hope you are ready for the next set of bazooka questions I've got here.
Bring it down, bring it down.
Okay. I've got one for Engineer Patrick Obidoyin here. Engineer Patrick Obidoyin would like to know first of all, he says thanks for the presentation. Also, Engineer Patrick Obidoyin would like to know, how do we take care of the services, electrical cabling, plumbing services, mechanical M&E in the design, and also what is the maintenance regime for modular buildings? And also we would like to know, what is the typical lifespan of our modular buildings? Over to you, sir.
Right, thank you very much. Services is seamless because everything is done on site. Your pipe are tied together, they're connected, they're checked on site. Your cable also, they just come to site and plug into each other. We design plugs, devices that will connect all your electric together from one module to the other, and also connect all your pipe, services together from one module to the other, and then onto the main. But one thing we do with service, we try to make sure all our services are going to a particular part of the building. Yeah, the vertical trench of the service is going through a particular part. So if there's any problem, you know where to go to check things out. Yeah. Maintenance regime, as I've said to you, modular have the very interesting, very low old life costing. Traditional building, within 6 months, something will have gone wrong and you have to call maintenance to come and check. Modular, seriously, because it's been tested, it's been improved, it's been released. Maybe in about a year or two afterward, maybe you start getting something. And again, if you do get something, it is very easy to fix. Yeah, it's not something that will be so difficult that you won't be able to get access to. Lifespan, I have a publication called The Durability of Light Steel Frame. Yeah, and we've proved with time, light steel frame or the cold form steel in different environment, we know it will last 200 years. So those modules, they could sit in there forever. I mean, 200 years is the time it will take to erode all the galvanized coating out of this material. And you only erode the galvanized coating if the material is in a damp or a wet or running water over it. Provided it's within the area where it cannot be subjected to any of this, it will stay in there forever. Galvanizing and purlin has been used for roof for many years, and they're still sitting on there, So we put a 20 years life on it because when we started this thing, the insurance company want to know how long this thing will last, and that's where we have to do a lot of tests to show that it will last over 20 years. And there's no building that I know.
Right. The plaza in front of the market. That's what I said.
Can you unmute those people? There's no building that I know that has a design life of 200 years.
Exactly in front of the market.
Excellent. Thank you, Dr. P.
So I hope I've answered that. Thanks, Patrick.
Definitely you have. And definitely from my own experience of MD, one of the main advantages of modular is the fact that on-site testing and commissioning becomes seamless because off-site testing has already been accomplished. So you know definitely that you are doing the right thing by testing and commissioning. Thank you very much for that, sir. Also, I've got 3 questions here. The one here definitely I know is going to be interesting to Dr. Popo-Ola. He says here that how do you manage changes during and before construction? And then how do you manage stakeholders' expectations, especially at site, which completely negates the concept of modularization? That question is talking about maybe stakeholders who don't have a clear understanding of modular construction. So how do we manage their expectations in terms of that? Another question here is how do we manage the gap in the substructure to make adequate provision for the superstructure, especially in futuristic purposes? And how do we manage material reactions in most times that there's a concept that is quite different from material being combined together. I think he has put here LSGP and CS. So in a nutshell, that question is talking about how do we manage the synergy of different type of elements we use in modular construction. Over to you, Dr. P.
Well, I'm going to start from the last one. There's not any different materials. The material we use in modular is exactly the same material you use on site. Yeah, there's steel involved, there's concrete involved, there's bolts involved. Yeah, sometimes we do welding, so it's no different from that. Yeah, so you don't really need to worry about that. It's all about talk about the gap between the substructure and superstructure. As long as you safely transfer your superstructure load to your substructure load, your building stands up.
Absolutely.
Yeah, anything you have to put in there to prevent corrosion or any other things, you put it in place. Yeah, it's just the time that it will take you to erect a modular is much faster than you would take to an NCQ where you have to wait for the concrete to cure before you put anything on it. Mm. Yeah, and then the other question, the manage changes during and after consultation, especially with the stakeholder. Yes, I'll show you the picture of the Korean where we have to convince the principal that this is the best thing for her to have this little area of the football ground converted to a classroom. And when we finish, it's not just that she bought it. The student didn't want to go into the other buildings anymore. All of them want to come into this building, although we can't fit everybody in there. They love the building so much that they want, I don't know what they're doing now that we have Corona. Those students you have sitting together in the classroom, I'm sure they're probably in a cage at the moment. I haven't seen a picture of them recently. I could ask them to send me a picture. But yes, it's beautiful. You know, there was even a statement once to say, I don't know how true this is, that modular hospitals in the UK, that people get better quicker in the modular hospital than in the traditional hospital. Don't quote me on it, but I've read it somewhere. So you just have to convince them, yes, and you give them all the benefits. You compare the traditional method to the modular method or the modern method, and you show them the benefit, especially for property development. They love this because before the building is finished, they're already collecting money. They're already renting things out because part of it is already finished. So they love this so much. For me, everybody wins.
Thank you for that answer. And then I have the last set of questions, unless we have any other question coming in. And it boils down to durability.
Why don't you allow that person to ask as well? If the person
there's no one here. There's no one yet, unless someone is coming up again. But
I think you need to raise up your hand if you want to speak, please. Raise up your hand and then we'll call you to speak.
Okay. Well, let me just take these questions first, Dr. Popo-Ola. I have this question about wind and fire resistance. How do we cope with that? How do we take care of that? What are the considerations for wind and what are the considerations for fire resistance in modular construction?
Okay, thank you very much. That's very important. For wind, most of these buildings, they have, as in traditional method, they have the core, the concrete core that goes up before the building is, before the module starts to be attached. You can see a core here already going up and the module is already on 4th floor. Yeah, and the core is still constructing the core. So that will take most of the wind. As long as the connection between the module and the core is perfect, the wind load will transfer onto the core. Gravity load, obviously you line up your module very well and everything transfer through the module onto the ground. Fire is interesting. I don't know if you guys know about Grenfell. I did a lot of work on Grenfell. Actually, my PhD was on recladding and overcladding of tall building, existing building. And I designed a lot of overcladding system using line steel frame, not aluminum as used on Grenfell. And when Grenfell happened, CNN was after me, BBC was after me, because when you Google overcladding, you see my PhD work. And they wanted me to be involved in all this thing. And all I said to them, actually, my employer didn't want me to be involved because it was very political at the time. But now I'm talking to them, I'm talking to the inquiry, I'm talking to the people behind, trying to make sure the British standard and all that, trying to make sure this kind of thing doesn't happen again. And the problem with Grenfell is what we call fire compartmentalization, fire barriers. Every floor, every 2 floors must have it. So that when a fire breaks in one floor, either from the window, whatever, it will not be able to spread to the next floor. Or even though if it spread to the next floor, it will spread in very, very slow, that people will be able to come out of the building. And that's what didn't happen in Grenfell. Between the existing cladding, the new cladding and the structure, there's a big void. And you only have to ventilate it with a bit of a air going through, and the fire, the whole thing just spreads. It's like you throw a ball of fire into the air. And that's what caused a lot of death in that building. So if you have a fire barrier between the new cladding they put on and the existing building, something to block the fire from spreading, you still allow air to flow through, and it still allow water that comes through the cladding to be channeled out, but it will not allow fire to rise. And that's one of the major problems. And that's why they're replacing all the building that's got that kind of cladding. Even this one here, which building is that? I think I showed it earlier, the Paragon building. Yeah, they've taken it down now. Last week, I don't know if you guys watch BBC, where they were saying that everybody in that building must vacate because the cladding used on that building was not the right type of cladding. And believe me, there's nothing wrong with the module itself. It's just the cladding. And they should have checked that long time ago to make sure. I mean, the Grenfell happened about 2 years ago. How come they've only just realized that the cladding on this one here, that the cladding on Paragon was not the right cladding? I'm very, very surprised about that. Yeah. But the module, there's nothing wrong with the module. That building is not going to be taken down. They're just going to replace some of the cladding. There's an hotel in front of this building called one of the famous hotel, not Travel Lodge. What's the other one? Start with a P. Anyway, there's an hotel in front of it. If you travel along this road,
Premier Inn.
Premier Inn. Yeah. The moment Grenfell appears and happens, they change all their cladding instantly, and I advise them to do so. Not just here, all the Premier Inn have used the kind of cladding. They've gone and spent money and replaced all the cladding. How come this particular building here hasn't been done? Is above me.
Thank you very much. Engineer Gabriel Igay, can you unmute and ask your question, please?
Yeah, good afternoon.
Good afternoon.
Dr. Sunday, thank you for such an exciting presentation. Yeah, my question basically, because I've done a few, worked on a few modular buildings for schools particularly. It's if in the future you want to modify, modify the classrooms or the building, the rooms, you want to make some rooms bigger or smaller, blah, blah, blah. How easy is it to modify, remove walls and stuff like that?
Yeah, again, if you think of doing that, then you have to use a system that allows the load to be transferred through the columns on the corner, like something like this, where, no, not even that one. Yeah, something like this, where the loads are transferred through these beams and the columns and the floor beam. And this infill, they're just partitions. They're not actually carrying any load. Yeah, so you can take any of these away and the frame will stay the same. And you have your bracing, as long as you don't cut your bracing as well, obviously. You know, the building stays the same. By the time you break through this wall, you will have seen the bracing, and a good contractor engineer will know the meaning why you have a brace there, and it will not cut it, hopefully. So yes, it can be done. You can turn this one into a bigger space by just removing this infill panels there. Yeah. And
what about from okay, sorry.
What about?
Yeah, sorry. Thanks. What about from a cost point of view?
Mm-hmm.
Which is, if you compare this modular with traditional form of building, which is cheaper or more cost effective?
Oh yeah, this to start with, it could be a bit more expensive to start with. But if you look at, as you always said, all life costing. Yeah?
Yes, yes.
The cost of maintenance,
right.
Sometimes it surpasses some of the costs you have to spend initially. So if you're ready to spend 10, 15% more now, you will recover that over time. There's no question about that. In terms of callbacks, in terms of maintenance and all kind of things, you will recover that in no time. But a lot of people don't see that. They just see the cost now. How much do I need to spend now? Am I going to spend 75 and 100 pounds now instead of 75 pounds? And they want to save that 25 pounds when they could actually save another 100 pounds with time.
Yeah. The other way you can save is that because these modular buildings are manufactured in a factory, you're not affected by weather. And so if you're you're not. So if you're building on,
not just in the factory, on site too, you're not affected by weather.
On site, you can even have it on.
Yeah, I'm saying if you're comparing with the traditional form where you're laying bricks on site, and when it gets frosty or it gets rainy, you have to stop work. So you can make some savings there, which people are not even factoring in with the modular.
Very true. And your building that you're building in Stratford, you should have consulted me on this. That building should have been finished by now if we use modular.
I like that.
But there's a limit. There's a limit to. I've done this exercise before. There's a limit to some of the heights you can go up with modular.
No, we're at 44 stories now. China is going to 60 story. I'll share the building with you when it's on site. 60 story they're going to with the same system.
But there's also a limit on the way the buildings look. Modular tend to be more box type.
Obviously, you haven't been watching this program with this presentation. I've told you there's no form you cannot make in modular. Those are old conception. Those are traditional conception. You want it as beautiful as you want, we'll form it for you.
Okay. So don't worry. The next UCL project will be, as far as you give me commission, my own manager. I'm only kidding. Anyway, thanks very much.
Okay, thanks for that, Engineer again. I've got Engineer Bamidele Downsy here, please. But Engineer Downsy, can you ask your question, please?
Yes, thank you. I would first of all like to thank Dr. Popo-Ola for a good presentation, and also for the good work that he has done with EFN, which he has also now transferred to NSE London branch. My main concern here is when you have saline environment. For example, we talked about Lekki the other time. How do we ensure the integrity of the connections, especially when the connections are with the metal? In saline environments, we know that rust will lead to some reduction in the strength of the materials. So how is that factored in? So that's my question. Thank you.
Right. Thank you very much. I mean, the life or the stability of any construction material or putting two things together depends on the life expansions of the material itself. Most boats, most connections, as I've said to you, this material, they're galvanized. They're protected against rain, water, and all kinds of things. And provided you don't have a standing water on them, they will not corrode. They may change color a little bit, but they will stay there. The integrity stays there. And with connection, it's the same thing. The boat, unless, I'm sorry to say, is back of the lorry boats, that it wasn't up to any standard. Then obviously with a little bit of condensation, then the boat would obviously corrode. But if you're using the right boat and using the right number of boats, when it says on the drawing 4 boats, don't put 2 to try and cut costs, then you're home and dry. Thank you very much for compliment about EFN and NSE. These are my baby. And EFN is still going very strong, and NSE have just started. These are my baby. We need to work with all these organizations to bring our knowledge up and basically make a difference in our country. So thank you very much for that, Engineer Bamidele.
Thank you for that. Can I have Mr. Jones Esson, please? Mr. Jones Esson, you can unmute yourself and ask your question, please.
Thank you very much. I want to also extend my congratulations and warm thank you to Dr. Popo-Ola. I really don't know how he managed to put all this together in spite of his busy schedule. Let me say this, what I'm going to ask is regarding what he can do for us. In our motherland, in Nigeria, many statements have been made in terms of what happened in Lekki and the like of it. But I'm also thinking from his PhD that he mentioned, can something be put together that could be shared? I'm sure probably he has done that before, I don't know, but I just want to ask, that could be shared with the building authority in Nigeria, where we see building actually collapsing every single time, and also looking at people building houses without thinking of their neighbors and basically obstructing them. Again, you might say that depends on the planning aspect of things, but I guess we can also start to say to the government, if there's a need to change, people like him should be consulted, and with others in Nigeria to see how they can make the point clear to the government and build a better city, beautiful city, like we see in different part of the world. Also, the last question is this: what can we do to change all the what's it called again? I don't know what it's called. What we use to cover these houses in Nigeria, aluminum plates, or it's not aluminum plate. It's, what is it called?
Galvanized roofing copper, whatever they call it.
Roofing copper, yeah. I mean, they're very ugly from the sky. When you're landing in Lagos and you look down, you just cannot imagine you're going to a city. You think you're going to a village. So, I mean, could anything be done to see that all those galvanized old plates, I mean, systematically by the government to change those things to something that is more healthy, more environmentally friendly, please? That's my question.
Thank you very much, Dr. Jones Esson. Thank you very much. Those are the thing that wakes me up in the morning. What can I do for my country? I don't think of what my country could do for me, but what can I do for my country? That's what always wakes me up. So for me, it is very important that we'll continue to give back to our country. About 10 years ago, when Donald Duke was the governor of Cross River State, he invited me to make a presentation based on this. And yes, he was about to invest heavily in developing a factory, a modular factory, which is going to cost about $10 million, I think, or is it 100 million? I can't remember. And within time at all, some of his opposition didn't like it, so they threw it out. And then obviously he finished his term. Then I went back to him a couple of years afterwards and said, listen, this thing we talked about, he has a house right here in Park Lane. So we sat in his flat, have a drink and all that. And he said, Sunday, this thing would be fantastic. If I was still the governor, I will bring investors to come and invest in this thing. Well, since then I'm not, I could still invest, but you have to do something that will use timber or concrete. I said to him, concrete will be too heavy. You could use the concrete maybe just for the floor. You can't use concrete for the walls and all that. That would be, it might as well use traditional method. So he wants me to go back to the drawing board and come up with something with timber, and he's ready to invest in it. So people like that will need it, but he doesn't have to do that. The government could do it. The private sector could do it. Dangote could invest in this with his eyes closed. Just give me $10 million, and I will build you a factory that will be chunking out modules. You know, people will be buying modules every weekend, and they'll be building their own house. The country is short of housing. And this is going to be the subject of my conversation, my presentation on the 12th of November at Buhari branch. I'm going to be talking about problem with housing in Nigeria. So that's that. What can we change for this galvanizing? I showed you some of the work we've done here. These are all galvanized as well. But provided you don't expose them into rain, into water, and no running water, they will change color, but they're still okay. But the problem with Nigeria, the galvanized they're selling us, made from China, made for all these things, they're so thin. You only have to have a little bit of rain and the whole thing starts to degrade. So the quality of that galvanized needs to improve. That galvanized sheeting, roof sheeting, it needs to improve. They should stop allowing horrible material into our country. Yeah, I mean, you fly to UK, you don't see some of those roofs you see in the UK, especially in the factory. They're made of the same material, but they're coated better and they're thicker to make sure they last longer. But we don't do that back home. That's what the problem is. Yeah, so somebody needs to change the law. The code and standard of Nigeria need to make sure the level of protection provided onto this galvanized roof sheeting are up to something. And that's the only way we could avoid that.
Oh, thank you very much for that, Dr. Popo-Ola. And I believe it happens to be one of the key areas of NSE London branch to really forge ahead to put together a standard for us for material testing in Nigeria, because Nigerian market is just flooded with inferior quality material. So we want to look at that as well. And that's a very good point you've raised there. Still talking about
just a sec. You're talking about what can we do? This is a copy of my PhD thesis here. Yeah, you see how thick it is. Yeah, that's my PhD thesis there, and it's got a lot of things in there that even I myself can't remember. I only picked it up when Grenfell happened, because there's a chapter there on Grenfell, on application of what happened in Grenfell on my PhD, and I've published 4 books on this book here, out of this book. So there's a lot of information that any country can take and run away with it. The Korean came and they took 2 chapters after this, and that's what they're doing now. Singapore is the same thing. Yeah, Ghana, I've done work in Ghana based on this book here. This is my Bible. I wake up in the morning and I think of this. Yeah. So anybody want to share my Bible with me? Come along.
Thank you very much, Dr. Popo-Ola. Just two questions, and then we can round up with a close remark and vote of thanks by Engineer Solomon. Just 2 questions, and it's bordering down on motherland Nigeria as well. One question I've got here is asking us if modular building construction can take place in any region, or what are the regional requirements for us to have modular construction in Nigeria? That's the number 1 question. And the second question is talking about Nigeria as well. The materials for modular construction, how readily available do we have them in Nigeria? You're talking about starting this in Nigeria on a large scale. Over to you, Dr. P.
Right, region, there shouldn't be any problem with region. I'll show you a building earlier, which is like a ghetto. Yeah, this slides here. That's in the middle of nowhere. And we've seen people building houses on top of a hill in the traditional method. So if you can do that, I don't see why you can't use module. It may have to go in 2D panels and then put together rather than as a complete module. Yeah, the building you see behind me, the tent you see behind me, the whole roof was constructed on the ground and lifted up. Yeah, that's my contribution to my village in terms of modular. So I showed them how to do it, and they did it. Material, yes, we have Ajakuta still, I said, operating or not operating, or not breeding or breeding. The Russian came, the Chinese came, everybody buy and take their little bit and run away with it. As long as we have something like that, and Nigeria is full of, resources that we can use to produce steel, to produce all kind of material. Look at how wonderful Dangote is doing with his cement. Yeah, and every week the cement is going up by 50 naira. Yeah, the last time I bought cement was 3,100. 2-3 months ago it was 2,500. So it's consumption, market for it. So if the steel manufacturing is good in Nigeria, then we'll start making use of it. So there's no problem with material. It's there. Currently, if you want to see light steel gauge, the closest you can get to, apart from going to other countries, South Africa. They have big manufacturing farms in there producing this thing. So people buy them for that. And people use them in Nigeria now for cladding, for partitions and all kind of things. So I've been to a factory in Lagos where they have machines to form all these sections. Yes. Yeah, I hope that answered that question. You're muted. You're muted, Theo. You're muted.
Okay. Thank you so much, Dr. Popo-Ola, for that. And we are rounding up on our program, our webinar program for today. Coming up very soon, it's going to be the same man again, the same genius coming up again on Saturday, the 12th of November, 2020 at 5 p.m. This time around, he's playing an away match in Nigeria. He's playing an away match in Nigeria, flying the flag, green, white, green. Dr. Popo-Ola will be on the next engineering webinar for the NSE London branch on the 2nd of November. And this time around, he's going to be talking about Nigerian housing crisis and infrastructure deficiency. The Nigerian housing crisis and infrastructure deficiency. So this webinar that we have this afternoon definitely couldn't have come at a better time to open our eyes and shine light into the crisis of housing in Nigeria. On that same day, Dr. Popo-Ola's program is coming at 5 p.m. and we are having,
No, it's not the same day. This is the 12th and this is the 14th.
This is the 12th of November. Thank you very much for that. And on the 14th of November, we're going to be having with us Mr. Albert Williamson-Taylor. Mr. Albert Williamson-Taylor, the design director and the founding member of AKT2 Consultants. We believe definitely it's got an insightful consideration for structural design as well in mind, and I'll see we can just move building construction to the next level. The next program we're going to be having on our webinar, it's going to be on the next slide, Dr. P. And yes, I don't know whether you heard Dr. Larry Jones' song asking a question the last time. Yes, we're going to be having the man himself, CEO of the Lagos Academy Business School, Labs. So Dr. Larry Jones' song will be with us on Saturday, 28th of November, 2020 at 2 p.m. And it's going to be talking about infusing knowledge management, knowledge management in higher education in sub-Saharan Africa, and going to be a case study of Nigeria. It's going to be looking at Nigeria as a case study to see how we can infuse knowledge management in higher education. To be followed by that, the NSE London UK branch will also be presenting a series of other webinars, which we are yet to kind of schedule and let us know about what they're going to do on that particular day. But we know definitely that we've been involved with so many negotiations with people, both here and in the diaspora, with other people in Nigeria as well, who are coming here on board to give us more lectures on how to move the technological advancement of Nigeria forward. This has been a very wonderful time this afternoon. I was so inundated with requests on the chat section asking for the copies of this slide for today, Modular Construction. So for those of us who are quite interested, we've got the email addresses there on the screen for us to send in our email addresses for us to get back to us. And also, definitely, we want us to remind you that this is just a body of interested professionals from Nigeria. We're coming together in the diaspora to see how we can put our knowledge back into the motherland. So if you are willing to join us with your expertise, definitely you are free to come on board. Drop us a line on those email addresses and we'll get back to you and we'll talk further and see how you can come in. And I want to say it's been a wonderful time with you, and it's been a wonderful time listening to Dr. Popo-Ola giving us this session. So I'm going to call on Solomon, Engineer Solomon, if you are there.
Yes, I'm here.
Let's give us a vote of thanks, and then we can round up for the day. Thank you very much.
Thank you very much. I want to especially thank Dr. Popo-Ola for giving us this very fantastic presentation. I think it's very, very relevant, not just for Nigeria, but also for Africa. I mean, when you look at the growing population in Nigeria and the projection of where we are going, I think this is very relevant, and I would advise that we take this forward. We continue to drive this discussion forward to ensure more affordable modular structures designs for Nigeria. So thank you very, very much, Dr. Popo-Ola. I want to also thank Engineer Halimat and Engineer Mayowa from the Buhari branch for joining us today. Your presence was really, really appreciated, and we can't wait to come to Buhari branch to present next month. Thank you very much for that. We also want to thank Buhari branch and the NSE London branch and everyone else who have joined us today to listen to this presentation, for spending your valuable time to get more knowledge and to support the branch, the London branch. We really appreciate your presence here, and we hope to have even better seminars going forward. But I think I just want to make one point here. I think when we look at all of the NSARS protests that happened in the past few weeks and how much the youths came across to air their minds and air their views on what they want and how they want to move the country forward, this should not stop with politics. I think that our youths, the younger engineers, I expect that I expect us to continue to do more. We need to be more vocal. We need to air our views more. We need to represent ourselves more within the profession. We don't have to be the best at what we do, but we need to be heard. So I would encourage us to speak up more, to ask questions more, and to volunteer more to ensure that we start getting all of the experience and all of the knowledge required to make NSE UK and NSE Nigeria much better than it is today. So thank you very much, everybody, for joining us.
Thank you very much for that. I just want to mention that we thank World Remit for making this happen. They pay for the Zoom payment we have to make, and also pay for the design of this flyer. So London branch is not incurring any cost in putting the presentation together. So we thank them very much, and we hope we will continue to work with them. And if you want to send money home, this is not something I enjoy doing, but I would say it. If you want to send money home, they're very reliable. I've been using them for the last 2 months, and their money, the moment you press the button there, it arrives on your bank account instantly. I also wanted to thank a couple of my colleagues. If I don't mention their name, they will think I've ignored them. We have the president or the chairman of quite a few branches on board. I know some of them have dropped out. We have Engineer Shehu from Glasgow, Engineer Shehu Mohammed also from Glasgow. And then from the Manchester, we have Engineer Patrick and Engineer Books. And then I have a cousin of mine that is always following me everywhere. That's Sheyi Oyiloye. Thank you very much for coming. Many more people I've seen on the chat, on the list here. So thank you very much for coming. It's been wonderful. If you need any support on there are some of the things I've talked about, or you have connections of where we can take this thing next to basically improve infrastructures or building or housing in our country, come to me. I'm your answer. So thank you very much. Have a wonderful weekend.
Thank you so much, Engineer. Engineer Dr. Sunday Popo-Ola for that. And we can all unmute ourselves and maybe say one word or the other of maybe encouragement and commendation. And, starting from Dr. Alimat, I don't know thank you. Engineer Dauda, we can see you that you're there.
Thank you.
Thank you for coming all the way from
thank you from Lagos
University. I recognize you.
Thank you.
Thank you very much. It's been a wonderful presentation.
Thank you very much.
Dr. Kamar was my course.
Thank you.
Engineer Ben, thank you for coming.
And thank you for coming.
Thank you so much, Dr. P. Thank you.
Thank you.
Abdulami.
You're welcome.
And thank you, London branch.
Thank you. Thank you.
Thank you, sir. God bless you.
Thank you.
Bye.
Yeah.
Alpha, did you get it?
Thank you, London branch. Thank you, Dr. Popo-Ola.
Thank you.
I mean, wonderful.
Thank you.
No money, I'm dashing.
Yeah, Lima, yeah, man. Wari branch.
Thank you. It's a
Thank
pleasure having you.
Bring water for me. You just.
Thank you, Engineer Lima. Thank you. Engineer Lima.
Yes, it's a pleasure having all of you.
Thank you,
I want to
Dr.
say
Sunday
that.
Popo-Ola.
Thank you. Thank you.
I appreciate you for coming. Thank you.
Thank you. Thank you. It was a great presentation. A lot of
Thank you, Dr. Popo-Ola. Check your chats, your private chats.
Okay. Is that Engineer Olatuji?
Yes,
Okay.
Dr. Popo-Ola. Thank you. Okay, thank you. I appreciate you. Thank you.
Engineer Ige, I can't just say but say thank you very much for being around, sir.
He's gone.
No, I haven't gone. No.
James is not a center back.
Mr. Odulabi, our favorite anchor. Our favorite anchor. Very soon will be the anchor for CNN.
CNN, long.
Why not? You have to dream big.
Maybe the table will show the table.
Yeah. Thank you, Dr. Sunday Popo-Ola. Thank you. Well done, Dr. P. That's a fantastic presentation. Congratulations to Engineer Alimat. Congratulations, madam. Well done.
Thank you very much. I appreciate you. Thank you. Thank you for helping us to promote this thing.
Thank you, Dr. Popo-Ola. Thank you. I really appreciate you.
Thank you. Thank you very much.
Dr. Popo-Ola, can I ask a question?
Yes.
You know, I didn't catch all your presentation, apologies, but from my experience of this modular buildings, there's a lot of steel, some structural steel, hot rolled, and there's also cold rolled steel.
Yeah.
The challenge I can see is that because there's one time I wanted to take a company to Nigeria that made all this modular stuff, but then the challenge was getting the steel in Nigeria. How do you envisage that working?
That's what I said towards the end, that if Ajakuta steel factory is going on, then we could do it. But in terms of, I mean, look at the offshore. They import all their steel. I don't think they make any steel in Nigeria enough for the offshore.
Yeah, because when we did the cost comparison, and we had to import the steel compared to traditional build, it was just too expensive. So that's one area that we really need to work.
It may be, but you have South Africa right in the corner there. You can get some of your steel in South Africa, and I've done that before. Especially the light steel. It's very cheap, and you can also import the steel from China. But whether you get the right quality or not, I don't know about that. But steel from China is very cheap. Even steel from USA is very cheap.
But the answer really is for us to manufacture our own steel, isn't it?
Oh yeah, that's the idea. But when the government is not ready to put their money where their mouth is, then how can you unless they sell the factory to a private like Dangote or somebody and then revamp it and start making steel? You know, we've got enough material for steel for the next 100 years in the country.
Yeah. So because even when you get to the ports, that's another challenge. Import duty and all that rubbish.
Yeah.
You can't even calculate how much they're going to charge you. It's all depending on some crazy man.
But I've seen bidding done. I mean, I work on bidding in Ghana, and we import all the steel, and it's still much better than doing locally. You have to work out the whole life cost. It's not just the cost of bidding.
Yes.
Which is your pet subject.
Yeah.
So,
Dr. Sunday.
Yes.
There was a discussion when we were talking about MDU the last time, and we're talking about inferior quality of materials. There was a discussion with some other colleagues of mine, and they were saying, talking about over designing with a higher factor of safety for the members. For example, talking about China, if you're not so comfortable with the quality, is it possible for you to, increase the factor of safety in your design for the members?
Of course you can, but where do you stop? How do you know which factor of safety will be good enough?
Yeah, material testing.
Yes, material testing. Yeah, of course you could do
material
that.
testing. Yeah, because they can just say use a higher factor of safety, and then you can get the required maybe strength for the members. But I think definitely.
But then
the reason why some of our building collapse. The reason why some of our building collapse in Nigeria is not just that, it's a poor material they're using, and they will sell C20, C50 or C40 concrete, they give you C15 concrete. So what factor can you put in there? The C15 can't carry the load that you want to use, and then they go on 2-3 years afterward, change the use of the building. They turn accommodation to a factory. Put machines on it. So all those things affects these things.
I think the bottom line is for us to have a very robust material testing regime in the country. If we have that, it will go a long way to really standardize quality in terms of all this material.
When it comes into concrete, I've given University of Lagos, I've given Ekiti State University enough machines that we use here to test concrete. So they can't say there's not enough facilities to test concrete. University of Lagos have one from me, and Ekiti State University also have one from me, free of charge.
Is that cube? Is that cube testing or
cube crusher and so many other?
There's the Smith. Is it Smith hammer or whatever?
Yeah, all of that they have it. Slump test, stain cones, all of that.
Yeah. Did you train them how to use it?
We refurbished our lab about 15 years ago, and those guys just walked into Imperial at the right time. I said, "It's all yours, take it," and they did.
Wow. When are you refurbishing your lab again, sir?
Send us some palliatives, and then we'll think about it.
Dr. Popo-Ola likes granite, so if you can get him a whole lorry load of granite, you get anything.
Yes, you know my style. Yes.
So when else you are refurbishing your lab, let us know, sir. So we come around.
No problem. No for COVID. Last year,
I've been to Dr. Popo-Ola's lab.
Imperial College dismantled 8 classrooms. I'm talking about not just classroom, computer classroom, computers, projectors. I'll put them onto container, and I've now created about 16 classrooms in my village now.
Wow.
What is going to be there? Yeah. But they won't do that now. They won't do that now in COVID now. They will not do that now in COVID.
Because of COVID, because they need them now.
Yeah. They don't actually need them. No students is coming to classroom anymore. Classroom is empty.
Okay.
Yeah. Yeah, less than 25% of our students are showing up in real physical now. Everybody is working online.
I've been to Dr. Popo-Ola's lab, so I get first refusal. Dr. Popo-Ola, do you remember?
Yes.
We are quite we are blessed to have this talk. But now let me go to serious talk about this. How can we push this forward to Nigeria? Where do we start?
I think if you could design a timber version, which I've been working on. But even timber, I buy timber in Nigeria. The way they cut them, the way they plane them, the tolerance will just be all over the place.
I think you've got to start with building control, because I've tried to do this before some years back. Your first stop, it needs to pass through building control first. Once you pass through that, then you can do a prototype.
Do you have a building control in Nigeria?
They do. They will suddenly appear when they don't mind when things are okay. But suddenly, when they see you're making money, that's when they will suddenly appear and say you don't have the permit for this. So that's my own advice anyway.
They do.
But what about if you take a system that's already proven and is working?
But in Nigeria, you have to have, before you build anything, you have to have approved drawings for planning and building.
Yeah, of course you have that. But if you have a system like modular system for building 2-bedroom house, and you've proved it, you've done it, it's being used in a foreign country and it's accepted and all that.
So do a prototype and get it through that system. Once it works, then you can now start investing. Otherwise, if you invest too much money.
That's what I remember speaking to you about this. Let's put 100K together and we'll show a prototype, invite everybody to come and see the 2-bedroom put together in one weekend. Then hopefully all those politicians' eyes will open up. They can start building houses for their girlfriends.
Yeah. You know what might be even better is if we engage like a developer first and take him through, and he can see the cost savings, he can see the speed, blah, blah, blah. Then he will work with us. You understand? I even pay for it because it's good if you have a project already that's ready to go.
The few developers I've had a conversation with, they're not ready to invest. Because this demonstration building, there won't be anything for them. It's a future thing. They won't get any money from it. They will spend money.
Right.
And they're not ready for that. Even ordinary 50K, they're not ready to give. But if I go and contest for what's that program on TV? That program they do on TV now.
Okay.
Miss Nigeria. What do they call them?
Want to be a millionaire or something?
No. The one they put everybody in the house and they start shouting.
Brother Africa, Big Brother.
Big Brother. You can imagine if I go and contest for Big Brother, they can pay me 100K anytime just in there. I'm creating chaos. If I'm in there and I'm creating chaos and abusing everybody and shouting they'll give me 100K. But if I want to do something like this, no, they're not interested.
They're not interested.
I think another way we can look at is we can look at people in the hospitality business, hotels. If we can really get anyone that is quite interested in developing an hotel or something like that, I believe modular is the best way for that. Modular is the best way.
It's good, but think of Corona now. Even hotels in this country are empty at the moment.
All right, everybody wants to stay in Airbnb.
But doctor, COVID will not be here forever.
Sure, very true.
We are bound to outlive it. I know that for sure. We are going to outlive COVID. There's no big deal. So that should not kind of deter us from thinking ahead.
Yeah, once we have a vaccine, yes, that would be possible.
So, Dr. Popo-Ola, are you going to send the recording?
Yes.
I'll send the recording, but I'm not sure about the presentation slides because we have to give advantage to our full member that are paying to be member of NSE London branch. We shouldn't be making all our presentation slides available.
You are going to be inundated with a lot of emails then.
That's fine. That's fine. Yeah, I know what to say. They should watch the presentation. They should watch the recording. The recording, all the information will be on the recording.
Okay.
Yeah. Don't promise anybody a presentation slide, please.
No. It was just for me. It was just for
only for a member. I mean, Kyle, they remember yours. You couldn't even give it up because your company issue.
No. Just for me. Just for me. The recording is okay.
You can take anything from me. You know that.
Yeah. In fact, I have a very close friend who's
you've always supported my charity, so anything you ask for, you get.
Okay. I have a very good friend who's a developer in Nigeria, but he's one of the directors. So I'll run it past him. See what he says. They're quite open-minded.
Thank you very much, Dr. P.
Yes, I mean, thank you for support. Solomon and yourself, you did wonderful today. Thank you.
No problem.
Yeah. I can relax now in 2 weeks' time, knowing very well you guys are there.
But soon, the anchor of the year.
The anchor of the year is indeed.
How are they?
But Suhana, money anchor of the year.
No. Don't start with me now. They take it easy with me now. Beg now.
I'm telling the truth now.
No.
I'm gonna stop recording, guys. We've been recording.
Oh, you're recording? Oh my God.
It's okay. We are not saying anything bad.
No, you can always kind of you can